All right, let's look at chlorite, which is a polyatomic. Determine the number of valence electrons and then draw the Lewis structure with minimized formal charges. So first I'm going to start with chlorine, which has 7. Oxygen has 6. There's 2 of them. And then I'm going to add the extra 1. So that gives me 8 plus 12, 20. 20 valence electrons. So there's that. Now I'm going to work on drawing this. So the first thing I would do is chlorine is listed first. So I'm going to put that in the middle. And I have 2 oxygens. I'm going to try making single bonds. And then count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So that is a possible Lewis structure. Now let's do formal charges. Remember, formal charges we want to be 0 if possible. Otherwise, if there's a negative, you want a negative to be on the more electronegative atom and a positive on the less electronegative atom. So let's see. So we have 6 minus 1. So that's -1. Here we have 7 minus 4 minus 2. So that's +1. And we should, again, sum up to the charge, which should total -1 because it's a -1 total. So 6 minus 6 minus 1 equals -1. So we have -1 plus 1, -1. So that's not bad, right? But we prefer 0. So the fact that we have a +1 and a -1 means we can probably get those to zeros if we build this a different way. So that's where they can get kind of tricky. So let's see, how can we do that? So we don't have extra bonds we can make. So we could use a double bond on an oxygen. And we keep the chlorine. So essentially you've brought this pair here into a bond, which means it's being shared with the chlorine, which gives more electrons to the chlorine, which is going to affect its formal charge. So now let's count them, right? We still need 20, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we're still at 20. Now let's do formal charges. Here we have 6 minus 4 minus 2, 0. So we'll see, and you'll see these trends that oxygen actually likes having a double bond. It gives it a 0 formal charge, or 2 bonds. You know, you might have like a carbon, oxygen, hydrogen, or oxygen bonded with hydrogen for water. Those are going to have formal charges of 0. So that's at 0. This is now 7 minus 4 minus 3, which equals 0. And then we still have 6 minus 1, -1, which we have to have a -1 because it is a polyatomic. So this is a better scenario because it's got 2 zeros and a -1. And the -1 is on the more electronegative atom. So let's give it a shot. Do some check. This one needs 2. And we can look at formal charge. So we have too many in the center, but chlorine is okay with that. There we go.